Today's lesson will be on adding probabilities. This should go on a new log page, and it should also go in your table of contents for log page 6, adding probabilities. Union of simple events. What does it mean for an event to be mutually exclusive or inclusive? Remember that mutually exclusive means that the two things cannot happen at the same time. Mutually inclusive means that the two things can happen at the same time. Can a card be both a king and an ace at the same time? No. So this is mutually exclusive. Can a card be black and a 6 at the same time? Yes. So this is mutually inclusive. You could have a 6 of clubs and a 6 of spades. The symbol for union is U. Okay, this means union. Okay, remember that we used this symbol earlier, A intersect B or A and B. Okay, this means the probability of A and B. When we use the U, this means the probability of A or B. Okay, this is an or, A or B. We read A, the probability of A union B. That's how you read this. When we want to find the probability of this or that, we're finding a union and we add probabilities. Remember here we're going to add probabilities. So the first addition rule is that the probability of A union B is equal to the probability of A plus the probability of B. Now what I want you to recall is that when we found the probability of A and B, we were multiplying. When we find the probability of A union B, we're going to be adding. Okay, let's look at example 1. A single six-sided die is rolled. What is the probability of rolling a 2 or a 5? Well, the first thing we're going to do is find the probability of rolling a 2. Well, that would be 1 out of 6. Then we're going to find the probability of rolling a 5. That would still be 1 out of 6. If we want to find now the probability of a 2 or a 5, remember this is or, the probability of 2 union 5, we're going to find the probability of rolling a 2, and then we're going to add that to the probability of rolling a 5. Well, the probability of rolling a 2 we just found was 1/6, and the probability of rolling a 5 is 1/6. So when we add those together, we're going to get the probability of rolling a 2 or a 5 is 2/6. Okay? I'm sorry, I should have put a letter A there. Example number 1, letter B. We're going to find a spinner that has 4 equal sections. So what we have is a spinner, it's a circle, and it has 4 equal sections, and they are colored red, yellow, blue, and green. What is the probability of landing on red or blue? So the probability of landing on red or blue. Well, the first thing we have to do is find out what the probability of each of these is. If this is a spinner that is divided equally, then the probability of landing on yellow is 1 out of 4, on red is 1 out of 4, on blue is 1 out of 4, and on green is 1 out of 4. So if we want to find the probability of red or blue, then we're going to find the probability of landing on red, and we're going to add that to the probability of landing on blue. So that's going to be 1/4 plus 1/4, which is 2/4. So the probability of landing on red or blue is 2/4. Now you try. What I'd like for you to do at this point is I'd like for you to turn off or pause the video, not turn it off, but pause the video and try letter C and letter D on your own. Tomorrow when you come to class, we're going to go over these two and see how you did. I'm not going to do these two in the video right now. So you go ahead and try these, pause the video, and try C and D on your own. If you do these in your logbook, do them in pencil so you can change them tomorrow if you don't get them right. Okay, hit pause. Great. Now the next thing that we're going to do is talk about the probability of mutually inclusive events. Mutually inclusive events are events that occur at the same time. Example, a student can be both a math and an art student simultaneously. So I can take math and art at the same time. So addition rule 2 says if two events A and B are inclusive, then the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. Okay, A intersect B is what they have in common. I'm going to move this down because I don't like the way that looks, so here it is. Okay, the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. We always have to subtract what they have in common because we don't want to include it twice. So looking at your addition rule number 2, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. So please make a note that this is a plus sign right here, and this is a minus sign, and this represents what they have in common. Okay? We have to subtract that out. We can't add it twice. Okay, let's look at a picture of this. If I can get the slide to go. There we go. Okay, subtracting the intersection. If we wanted to find the probability of A or B, we have to subtract their intersection so that we're not counting it twice. Look with me at this. The probability of A, the probability of B, and this is the probability, or I'm sorry, this is A and B. Okay, so everything in this circle is in A. So when I find the probability of A, I'm using everything in that circle. When I find the probability of B, I'm using everything in this circle. I've actually counted this part right here twice because it's in both circles. I can't count it twice, so I have to subtract out, excuse me, I have to subtract out that intersection right there one time so that we are not counting it twice. Okay, example number 2. Find the following probabilities. Say, let's do letter A. The probability of a king or a heart. The probability of a king or a heart. Well, the first thing we need to do is find the probability of a king. So the probability of a king, there are 4 kings in the deck out of 52 cards. So 4 out of 52. The next thing that we have to do is find the probability of getting a heart. The probability of getting a heart is 13 out of 52 because there are 13 hearts out of 52. Now, we have to subtract from this the probability that the cards might have been a king and a heart. The probability that the card is a king and a heart. Okay, the probability that it's a king and a heart would be 1 out of 52. So 4 out of 52 plus 13 out of 52 minus 1 out of 52. So when we add those together, we're going to get 17 out of 52 minus 1 out of 52, which gives me 16 out of 52. The next thing that we're going to do is look at letter B. And we're going to find the probability that we are going to draw an ace or a red. Okay, so the first thing we have to do is find the probability that we get an ace, and to that we're going to add the probability that we're going to get a red, and then from that we're going to subtract the probability, let me scoot over just a little bit, that we would get an ace and a red. So the probability that we would get an ace is 4 out of 52, and the probability that we would get a red is 26 out of 52, minus the probability that we're going to get an ace and a red. Well, how many red aces are there? There are 2 red aces. So 2 out of 52. Okay? So we're going to now say 4 plus 26 is 30, minus 2 is 28 out of 52. Okay, now I'd like for you to pause, and I would like for you to try letter C on your own. When you've tried letter C on your own, you're going to open the next video and look at part 2.